Good day, everyone, and welcome to Module 2, Unit 3 of our course on Quality Management and Control. My name is Dr. Ahmad Huzaimi Ibn Abdul Jamil, and I will be your instructor for today. So in this unit, we will examine 7 critical areas that will strengthen your ability to manage quality in projects. These areas include root cause analysis, data quality analysis, and representation, inspection, and quality assurance, quality audits, corrective actions, developing a quality team and culture, and managing quality issues with project stakeholders. We will begin with a thorough explanation of each concept to ensure a solid understanding before moving to relevant examples drawn from a real-world project management context. Now, root cause analysis, often referred to as RCA, is a structured approach to identifying the underlying cause of a problem rather than addressing only its immediate symptoms. So the purpose of RCA is to prevent the same problem from recurring by ensuring that the fundamental cause is eliminated. The process begins with a clear definition of the problem, followed by the collections of relevant data. From there, potential causes are identified and examined until actual root cause is verified. Once the root cause is confirmed, the team implements targeted solutions and monitors them to ensure they are effective. There are several tools commonly used in RCA, such as the 5 whys method, where a team repeatedly asks why until they reach the underlying cause, and the fishbone or Ishikawa diagram, which helps organize possible causes into categories such as methods, machines, materials, manpower, measurements, and environments. Another approach is fault tree analysis, which uses a logical sequence to trace the origins of a problem. In a construction project, for example, a bridge structure may develop cracks in its concrete piers within months of completion. Without RCA, the team might simply patch the cracks, but an RCA could reveal that the issue is actually due to improper curing caused by unrealistic schedule compression. So the permanent solution would then involve adjusting curing procedures, improving scheduling, and ensuring that quality controls are strictly followed during constructions. In an IT project, system slowdowns in an enterprise resource planning implementation might be temporarily resolved by restarting the server. However, RCA may uncover that the database queries are poorly optimized and that the server hardware is insufficient or peaks loads. Addressing these technical deficiencies provide a long-term resolutions. So in manufacturing, high touchscreen failure rates in smartphones might initially seem like a production flaw, but RCA could trace the issue to moisture damage from improper storage conditions before assembly. Now, correcting storage practices would then eliminate most of the defects. Now, data quality analysis refers to the process of ensuring that the data used for project decision making is accurate, complete, consistent, and up to date. Accurate data means the information is correct and free from error. Completeness means that no required data is missing. Consistency means that data is uniform across various systems and formats. The timeliness means that data reflects the current situations and is updated regularly. Now, data representation is actually important because even the most accurate data will fail to influence decision making if it is not communicated clearly. Representing data effectively allows project teams and stakeholders to quickly grasp the meaning behind the numbers and make informed decisions. Now, tools such as control charts can reveal whether a process is stable over time. Pareto charts can show which issues are most significant, and histograms can help visualize the distribution of values. So in a construction project, daily site progress reports may understate delays if some subcontractors fail to update them promptly. So these incomplete data can create a false impression that the project is on schedule when it is actually behind. Now, in manufacturing, a Pareto chart might reveal that the majority of defects in an assembly process originate from just 2 stages of production. Now, these insights allow managers to focus their improvement efforts on those stages for maximum impact. Now, in an IT context, a control chart tracking system performance over several weeks may show a gradual decline in response times, now signaling the need for corrective actions before the system reaches a critical failure point. Okay, now inspection and quality assurance, while related, serve different roles in quality management. Inspection is a reactive activity that focuses on checking deliverables after they have been produced and ensure they meet specified requirements. Quality assurance, on the other hand, is proactive, involving the development and implementation of processes that prevent defects from occurring in the first place. Inspection verifies conformance, whereas quality assurance ensures that the processes leading the deliverables are robust enough to consistently produce quality outcomes. Now, in a construction project, inspection may involve examining completed weld joints to ensure there are no cracks or weaknesses, while quality assurance focuses on ensuring that welders are certified, that welding equipment is calibrated, and that proper procedures are followed throughout the welding process. Now, in software development, inspection is the testing of a finished application to identify bugs, while quality assurance ensures coding standards, peer reviews, and automated testing procedures are built into the development cycle to prevent defects from being introduced. Now, in manufacturing, inspection might involve random sampling of products after they are made, whereas quality assurance ensures that raw materials are verified for quality before production begins. A quality audit is a formal and independent examination to determine whether project activities comply with established procedures, policies, and standards. So this purpose of a quality audit is not only to detect non-conformance, but also to identify opportunities for improving processes. Now, audits can be conducted internally by the organizations or internally by independent third parties. Now, in a public housing project, for example, an external quality audit might be conducted to ensure that the procurement process adheres to the government's regulations and that all materials meet the specification set in the contract. In an IT project, an internal quality audit might review whether the development process aligns with recognized software quality standards such as ISO and IEC 25001. Such audits provide documented evidence of compliance, which is important for regulatory contractual purposes, and they also help uncover inefficiencies or risks that may not be immediately apparent during day-to-day operations. Now, corrective actions are deliberate measures taken to eliminate the causes of identified problems so that they do not occur again. So this process begins with identifying the problems and confirming it through investigation. Now, the team then performs root cause analysis to determine the underlying issues, implement solutions to address it, and monitors the results to ensure that the problem has been permanently resolved. For example, in a construction project, repeated cracking in concrete beams may lead to corrective action plan that revises curing schedules, implement better environmental controls, and reduces additional inspections during curing. Now, in manufacturing, misaligned sealing machines might be the cause of the frequent packaging failures. The corrective actions could involve recalibrating the machines, retraining operators, introducing a more rigorous maintenance schedule. In an IT environment, if security breaches occur due to weak authentication, corrective actions might include upgrading firewalls, strengthening authentication protocols, and training staff on cybersecurity-based practices. Now, developing a quality teams and culture is a strong quality culture is one in which every member of the project team understands that they have a role to play in achieving high standards. So this culture is built through leadership, commitment, continuous training, open communication, empowerment of employees to take action when quality is at risk, and recognition of quality achievements. Now, in construction, this might mean creating a system where any worker can report unsafe and substandard practices directly to management without fear of reprisal. Now, in an IT project, it may involve empowering developers to speak up when deadlines are unrealistic or when quality standards are being compromised. Now, in a manufacturing setting, a company might introduce a quality hero recognition program for employees who prevent defects before they reach the customers. Now, such initiatives encourage proactive involvement, boost morale, significantly reduce the occurrence of quality issues. Now let us look into managing quality issues with project stakeholders. Okay, managing quality issues with project stakeholders requires honesty, transparency, and collaboration. Now, when a quality issue arises, it is essential to communicate the matter promptly, explain its potential impact, and propose realistic solutions. Involving stakeholders in the decision-making process not only helps resolve the issues more effectively, but also maintains the trust. Now, in an IT project, for example, if a major software bug is discovered close to the go-live date, the project manager should immediately inform the client, present the possible options, and discuss the threats of each. Now, decision to delay the launch of implement a phase release should be made collaboratively. In a construction project, if the delivery of critical material is delayed, stakeholders should be informed and early so that alternative solutions can be explored together, whether that means adjusting that schedule or sourcing from a different supplier. In conclusion, the 7 areas we have discussed today, from the foundation of effective project quality management, the root cause analysis help prevent recurring problems by addressing them at their source. The data quality analysis ensures that decisions are made based on reliable information. Inspection and quality assurance work hand in hand to verify and maintain the standards. The quality standards provide an independent check that standards are being met and identify areas for improvement. Corrective actions ensure that problems are resolved permanently. Now, a strong quality culture empowers all team members to take ownership of the quality, and effective stakeholder engagement maintains trust even if the face of challenges. In the next unit, we will explore quality standards and objectives, where we will look at how to set measurable quality targets that align with the overall goals of the projects. Thank you for your attention, and remember that quality is not just about the final deliverables, but it is about how every step in the process is carried out. Before we wrap up, let us do a few quick activities to reinforce today's concept. Mini root cause drill. So I will describe a brief project problem, and you will take 1 minute to think of at least 2 possible root causes. So the problem is a newly launched e-commerce platform crashes whenever more than 500 users are online at the same time. Now think about what might be causing this and which tool you would use to investigate it further. Thank you.